everyone. Welcome to our CCNA 2 lab class. So we're going to talk about some labs here. First thing, I've had a request to look at this particular lab, which is our Vlan routing challenge. Now, we don't have time to do every single bit of this, but you can see the instructions are pretty narrow here. And the reason being is when they give you a challenge lab, they expect you to have done the other labs and they expect you to use those commands. Now, one of the things I've taught you and have talked a lot about is I strongly recommend that you are creating yourself a list of commands. So if you're going in there and for instance, so say switch, you should be making a little notebook that is something like this. It says config, and let's say we want to create VLANs. Well, the way to create a VLAN is VLAN and then some number. So the number. And anytime I put something in brackets, that means it is a variable. And then that, of course, will change it to switch config dash VLAN. And I'm much better at this when I'm writing in a book, not. And then, of course, the next item you would do would be name, and you'd give it the name of the VLAN. So whatever the name is. So you need to be creating for yourself a list of commands that you can have available so that you know the commands. This is very important. This is something I strongly recommend as you're doing labs, be building this command cheat sheet, shall you say, so that you have them. You also know that that's something that's very important for your students because they're going to need to know that in addition to that. So this lab assumes that you built that cheat sheet. And one of the things that it does here is it says you're going to configure the IP addresses to R1 and S1 based on the table. You're going to configure the default gateway on S1. And one of the things here that you need to notice is S1 is using the VLAN 99. Okay, so that is the management VLAN. Management VLAN is 99. Now they're using a best practice of actually setting the native VLAN to an unused VLAN, which is excellent. So this challenge lab is actually doing real world things. So what I would do here, first thing is I'd just go to the switch. All right, I'd go to the switch. I'd go in here and I'd do a, it doesn't matter. They're not asking you to put passwords on it. So don't do a password. Don't worry about it. Leave it the way it is. But it says put an IP address on switch 1. And so I'm going to look here and it says for switch 1, put the IP address on VLAN 99. So we go into global config. We'll do interface VLAN 99. And before I do it, I'm actually going to do show VLAN. Let's see if the VLANs are created. No VLANs are created, so we know that. So then we'll put in here IP add 172.17.99.10. Did someone have a question?
No, I was just giving you the numbers.
Okay, thank you. And then I'm gonna do a no shut, even though I really don't need to. Type exit here, and I'm gonna do show VLAN, and that really should have created VLAN 99, but if it didn't, I can do it. So the other thing we have to do here is it says create and name all the VLANs and assign the ports based upon the table. So let's look at our port here. So on the switch, we need to create VLAN 10. Name of faculty, staff, up arrow because I'm lazy, VLAN 20, name students, VLAN 30.
Guest.
Yes. Now, one of the things you have to do to get the correct points, because it says default, you would want to put it in there exactly the way it is, otherwise it will not give you the points for it. So just be aware of that can get you into trouble if you're not careful. And then let's see, VLAN 88.
Native.
VLAN 99. The second I make VLAN 99, it goes active. Name management. Okay. So our VLANs are created. Now we got to do put our ports into the correct VLANs. So we do interface range FA011 to 17. And remember, -17. So we got our range. Remember, we got to do switch port mode access first because these are access ports. And then we'll do switch port access VLAN and these are in 10, so 10. Hit the up arrow. Okay, don't ever retype things you don't have to. 0/18 to 24. Up arrow a couple times, access, VLAN 20. Up arrow, ports 6 to 10, 06 to 10. Switch port mode access, switch port access, VLAN 30. You'll notice that we'll find out gig 01 is native 88 because it's going to be a trunk here in a minute because we need to do that trunking. So let's do a do. Let's actually do an exit. Let's drop out because in the real world, you wouldn't see these VLANs completely until you drop out of config mode. So let's do a show VLAN. You'll see now we've got our VLANs created, 10, 20, 30, 88, and 99. There are no ports in these right now because we're going to end up here in a minute and you will not assign that to gig 01. That'll be a trunk. So we'll see that in a second. So it says here, we'll do that in just a minute. You'll be able to see it. And we got all of our ports in the correct VLANs. All right, and let's see. All ports that are not assigned should be disabled. Okay, so that tells me I need ports 1 through 5 in gig 02 to be disabled. So I do config T, config T, int FA0/1, 5, interface range. Shut these down. All right. And gig 02, I would also shut it down. Okay. So now I've shut down any unused ports. Okay, everything there is good. The only thing I need to do is I need to set the default gateway. So the default gateway here is going to be, should be IP default dash gateway. It's going to be the IP address on the 99 interface on R1. So go in here and put 172.17.
99.1.
99.1. So that's got that. I'm going to do a do right to save it. And let's see if I got everything on the switch. The only thing I need to do on the switch is configure G1 as a trunk. So let's go to interface gig 01. What's the command to make this a trunk?
Switch port.
Switch port mode trunk.
Switch port mode access.
Yep. So no, switch port mode trunk.
Mhm.
Switch port mode trunk makes it a trunk. And then we need to make the native VLAN 88. So then we do the command switch port trunk native
Oh,
VLAN 88.
okay.
Now, there's another optional thing here that they're not asking you to do that you could be asked to do on the exam or in the real world, and that is your switch port trunk allowed VLANs, setting the allowed VLANs. We're not going to set it. We're going to allow all VLANs. So now if I do a do show int trunk, you will see, well, there's no trunk because it's not up yet. We haven't brought the reason this is not up yet is because if you'll notice, if I do a do show interface G01, you'll see it's not up. It's up, down, or it's down, down access, down, down. And that's because the router is not configured yet. We have now configured everything on the switch that is necessary to meet the requirements. So I'm going to do a do write. So I write this one. Now let's go to our router. And that's why you see the link being down there, folks, because the router by default, the interfaces are down. We'll do a config T, config T. And we're going to go into interface gig 00. All right. And I'm going to go ahead and do a no shut. All right. So that's there. But now we need to build our sub interfaces. So we're going to go interface G00.10. All right. And I'm actually going to jump out of here real quick. I want to do something. So you notice how it was doing. I was getting my input was being on the middle of the line here. I'm going to go ahead and put in logging synchronous so I don't have to deal with that. So I'm going to go back over here and now when those things happen, I won't have that problem. So I need to associate this sub interface. Actually, I'm in the wrong. I'm in the wrong one. Okay. Notice I messed up, folks. I'm supposed to be in 0, 1, not 0, 0. So let's do this. Exit, and let's do no int g 0, 0.10, which by the way, if you don't need something 99% of the time, you just put no in front of it. So I was using the wrong interface. I was actually using gig 0, 1 instead of gig 0, 0, 0 instead of 0, 1, and 0, 0 is this outside green interface here. So let me start and go back. So int g 0/1.10. Now we need to associate this with VLAN 10. So we do incap .1q, and then we do 10. That associates now everything on this interface will be tagged with VLAN 10. We put in our IP address 172.17.10.1, which by the way, you'll notice if you can do this, if you can make your VLAN number and your subnet ID the same, it is very, very helpful for you from a network management standpoint. So let's go back in here and do
How
20.
about the safety?
Okay, go ahead. Yeah.
Safety, it really has nothing to do with safety. It just makes it a lot easier to keep up with your networks.
So I read the book said you must do it all the time. I read the lecture notes there.
No, you do not have to. I'll show you. No, they do not have to match. That is not correct. So watch this. Now, what does have to match is this. You want everything on this 1.10 to be tagged with VLAN 10. So that number right there has to be 10 to tag it with 10.
Okay.
All right. But let me show
The
you what.
subnet is not.
Yeah, let me finish this one and I'll show you. So this one, we're going to do VLAN 20. I'm going to hit the up arrow because I'm lazy. And I'll change this 20.1. But let me show you what we could do. Now, you could very easily do the following. You could do 31 and do incap.1q 30. Those numbers do not have to match. So this interface number here does not have to match what the VLAN is. It is highly recommended you always do that though.
Okay. So my original question is about the subnet and the VLAN. So they
Yep.
said you should have the same number, right?
They do not have to. No, they
Okay.
do not.
Okay.
That is, it is it's an industry best practice to always do that, but it is not a requirement.
Okay. All right.
So yeah, you don't have to have it that way, but it is a best practice and we all pretty much abide by it. Just because it makes life so much simpler on all of us. Okay, so there's 30. 88, which I don't really know why they're doing an actual 88 interface, but that's okay. We'll humor them. I would not have even made an 88 interface, but that's just me. Oop, I forgot to do my encapsulation. .1q88. And you'll notice you'll get that error message if you try that. It tells you can't do it because it's not part of a .1q VLAN. So there's 88. And last but not least is interface 99. Make it part of the 99, tag it with VLAN 99, and then we will change. You see how much faster I am using these up arrow keys, folks? That makes you very fast and very efficient. Now see, here's the key. We go into the server room and we say, oh, this is going to take hours. And we get it done in about 30 minutes and we sit there and charge for 3 hours. No, I'm just kidding. Just kidding. That's not what we do. But you can be very efficient when you learn to bounce around using your commands like this. All right. So we have created and assigned the sub interfaces that are necessary. In fact, if I do this, the only thing I got to do now is you will notice is I will do a do show IP int brief. And you'll notice the problem I have at this moment is my main interface is not up, so none of my sub interfaces are up. So I still need to go into interface gig 01 and do a no shut. And then now, if I run that same command, you will see that all of my interfaces are up. We'll also see we're at 96%. So we pretty much have just finished this lab completely. Let's see what else. Really, at this point, you should be able to ping from anywhere to anywhere. So let's see if the IP addresses are set on these machines. They are. So let's try to ping. This is PC1, so let's ping 172.17. Let's just do 99.10. Let's ping over to the switch, see if that works. And it probably fell a couple times and then start working. Unless I mess something up.
That's what I get.
There it goes. It started working. So it fails 2 times and then starts working. So I got to 99.10. So that's PC1 going to the switch. If I go to PC2, it is
10, 20, 22.
Yep. So let's do 2022. It'll probably fail the first time and then be good the next 3. It's typically the way packet tracer works. And that's because it's figuring out the ARP cache. That's really what it's doing. Real world, it wouldn't fail like that. But all right, and then we'll do 3023. And we'll fail the first time, be good the next 3 more than likely, unless I mess something up. There we go. And let's ping the server all the way on the outside, which is 172.17.50.254. Let's see if that works. Which it should. If it doesn't, we can figure out what's going on with it. But let's go over here and look and see if what we'll try to do from the router. Let's just, oh, there it goes. It started working. It just took it a while, which is crazy, but it did take it a little bit. Now let's go see what we missed. We got 4% we missed for some reason, and I guarantee you it's probably, sorry everybody, I'm sending this to voicemail. More than likely we just missed a small item, not that. Let's see. No, not that either. There it is. Oh, there it goes. It just telling us. So what did we miss? It says the native VLAN is wrong. Oh, it is definitely wrong. No, that's not. Oh, yep. We screwed up. I did mess up. Notice what I forgot to do. Okay, watch this. Do show run. Look at interface gig 01.88. What did I forget to do? I forgot to make this native. So what I need to do is I need to go back to interface gig 0/1. Wow, hit the wrong button, y'all. 0/1.88. Okay. Incap.1q 88 native. Do right. And in fact, I'll bet you money if I close this, if I go back to the switch, there were, okay, it's not saying, but there, in the real world, we would have been getting messages saying that your native VLAN mismatched on the interface. All right. But you can see now we got 100%. Well, we should have 100%. Where my little documentation is. Yep. 97. So what are we missing now? So we got that. The VLAN name. Okay, so it didn't like my VLAN name for 30. So maybe it did not want default in there. So I would have left. That's typically what I would have done, but let's say it doesn't want that. So let's go to VLAN 30. And let's just give it a name of guest. And you'll see it's still not giving me correct.
The problem was you had a space between the T and the open parenthesis on native.
Oh, did I? You mean guest?
Yeah, guest,
Okay.
open parentheses, default. I'm sorry.
Yeah, there was. Oh, okay. Wow. I had put a space. Okay. Holy moly. That's one of the reasons I don't typically grade names based on case, but either way. So now I've got 100%. So we have now configured the router and the switch for inter VLAN routing. you'll notice what we did on the switch. We created our VLANs, we assigned ports to VLANs, and then we created our trunk link. On the router, we created our sub interfaces, assigned the sub interfaces to the correct VLANs, and then that enables trunking across this link right here. And if I do this now, if I go to switch 1, let's exit here. Let's actually do a Control Z. I do a show int trunk, and I show interfaces trunk. You'll see that I've got gig 01 is trunking with a native VLAN of 88. And you'll see that we're trunking for, or we're allowing all the VLANs 110, 20, 30, 88, and 99. If I do a show VLAN, you will see that I have all the VLANs created. Now, what I would do if it was me is I would, of course, made a black hole router and parked these guys out in a black hole router because they're not being used, or out on a black hole VLAN. But they did not do that in this particular challenge lab. But otherwise, this is a pretty realistic view at how you would do inter VLAN routing in a small environment. Questions about this? Folks, this is actually how I'm thinking about doing my network at home when if I ever get Starlink, because what I'm going to do is I'm going to create multiple VLANs, and for a little while I'm going to have 2 internet service providers. I'm going to have it where I can jump between the 2 depending upon which one's faster, and use it. And so I'll have one VLAN that is Starlink, one VLAN that is Windstream, and I will jump between those 2 based upon the needs that I have and how it's working. So this has applications even in small houses. In fact, I'll probably even set up a wireless VLAN and have the wireless VLAN get routed out through the Starlink versus the Windstream, so we could do it that way. So be aware, this is something that's out there and it's used a great deal in the real world. Questions about this? This actually got a good little stepping off point for me right here, though, because I can step off from here to talk about spanning tree.
By the way, I finally got that portable command book came in.
Good.
But just a hint for the other guys about making the cheat sheet.
Yep.
I use the snipping tool and
Yep.
take it right out of the lesson and
Yep.
snip it and paste it onto a Word doc. And that way I can rearrange it and play any way I want.
That is an excellent idea. And I'll tell you what else I do is this. So like if you're inside of you're actually looking at it and it talks about how to configure, well, that's troubleshooting it, but let's go in here and let's look at how to configure here.
Troubleshooting too.
Yeah, let's see it right on stick. So let's say sub-interface configuration. So here's an actual set of the commands where it's showing you this. So what you can actually do is if you've ever used OneNote, anybody used OneNote before?
Yes.
This is a really good tool. Get your hands on OneNote if your college has it, and you can just make you a little section that says CCNA commands. All right. So I got an entire section where I was studying for different things. All right, but CCNA commands, and then you can go in here and, like you said, just take the snipping tool, and of course I've got this in the way now, but take the snipping tool, grab it, snip out how to create VLANs and name them. Boom. Control C, pull up your notes, Control V, there it is.
And that's exactly how I'm doing it.
And the good news is with this, you actually, you can put your OneNote onto your OneDrive or onto your Google Drive or whatever, and you have access to it all the time, wherever you're at. So it's a really good way to study for the CCNA and to make that notebook. Excellent. And I actually have to credit Michael Bowden, our support specialist that we hired, for getting me started doing that. I was old school. I was using a real book. I put my stuff in, I wrote it and all, and then Michael was like, oh, I use OneNote. And I was like, if I do that, I'll have access to it on every device that I have. That's smarter. And so I started doing that.
I like you, all right, old school. I just wrote document down, and that helped me to memorize. Otherwise, forget.
Yeah, and that's another. I will say that's another thing, Dr. Who, that helps me a lot too. If I write it, it helps me remember.
So far, I have wrote like 30 pages of notes already.
Oh, that's excellent. Excellent. Okay.
Is there a book that have all the command for the router and then the switches.
Not all the commands, but I will say that this is a good command, or this is a good book here. It's the one that we used to have inside of, we used to have it in the O'Reilly, but they took it away, but it says portable command guide. So this is,
I just got it off of Amazon, Kelly, and it is a magnificent book, easy to get through
yeah.
and use.
I swear up and down they stole it from me, because years and years ago, before they ever did this, I went to a Cisco conference with the Academy and said, you know what'd be good would be a book that had all the commands in a shortened form. And lo and behold, they came out with it. So, but you'll notice just like this, as you go through here, it has how to do everything, how to put an IP address onto an interface. So let me scroll on down. I can get down here and I'll show you actual command, but it actually has like all the commands. It's got some stuff on the basics on how to do things, but it also talks about how to, every command that you want, basically that's in the CCNA is in here. So it will tell you everything you need. So, and it's a cheap enough book, and you can get them. I mean, you could buy it yourself, or you could probably, you can get these free from your Pearson rep, if you got a Pearson rep. But I would strongly suggest purchasing this book and having it around. I'd also actually suggest buying a couple copies and having them in your classroom, so that, you know, you can do, when you do like a challenge lab. That's one of the things I wish we had seated classes with you. I know it'd be very hard because we're spread out all over the place, but I'd love to have y'all in a lab with me, because one of the things I do in my lab is I'll walk in and draw on the board a network, and I'll say, here's your IP address, subnet it, build this, and I'll turn around and walk out of the room, and I'll say, you've got 2 hours to build this, and then they have to build it. And you know, I'll walk in, you know, 15 minutes later, I'll come back in and say, okay, show me what you got, and kind of, you know, make sure they're actually working. But it's one of those things to where it gives them a chance to have to learn without me being there right over their shoulders. And having a couple of these sitting around in the classroom, that way, if they don't remember a command and for whatever reason don't know where to look it up inside of NetAcad on the curriculum, they're able to jump in here and look at it quickly and get it. So very good book. I strongly recommend it for you and your students.
How about the Cisco website?
The Cisco website actually has every single command you could ever want, but it is a little bit tough to get through. You know, you can Google every command, but it's still, the good thing about that command reference is it's only the commands that apply to the CCNA. And the other thing is they are designed, that book is designed around the equipment that you're going to have in your CCNA lab. A lot of times you'll go to the Cisco website and the commands may be referencing a switch version or switch iOS you don't have, and the command's slightly different.
I've noticed that it's different switch that they had the command on it, but you have to twist it to see how it works with the old one that you have.
Exactly. So the Cisco site is very good, but many times you have to really kind of massage it to make it work on our equipment, because it may give you a higher end switch or a lower end switch or an old command that no longer is actually used in the iOS. So just be careful with that. It's good, but it's not the be all end all. All right, let's talk a little bit about spanning tree. Now, one of the things that we have discussed and we have done a good amount talking about is we have talked about the fact that, you know, at layer two, what is the protocol data unit? What is the PDU at layer 2?
Frame.
It's a frame. Very good. Yes, it's a frame. All right. And if you remember, when we looked at a frame, the basic frame, and I'm not going to get every single piece of it, but we know in the header of a frame, that's a, ooh, golly, that's terrible. Let me start over here. There's the destination MAC address, right? So we got destination MAC address, which is 48 bits. We've got the source MAC address. All right. We've got some other things in here like a type field. If we have .1 queues, they would be in here. Then we have this data. Okay, so this is all the information from the upper layers. And then we have a little CRC here at the end, right? So that's our trailer, the CRC. But inside this frame, the one thing I never mentioned and never talked about at layer 2 was any kind of time to live mechanism. Okay, so there's nothing in the layer 2 frame that gets decremented when a frame goes through a switch at all. Now, that causes some major issues for us when we do something like this right here. Okay, if we don't have spanning tree, let's imagine, all right, I'm going to actually put a PC here. Okay, and I'm going to put a PC over here. And let's just say that this is PCA, PCB. All right, so PCA sends a broadcast message. So that broadcast message will come in. And remember, a broadcast would be going to the MAC address of all Fs. So it'd be 12 Fs. There's 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 Fs. That's the all ones MAC address. What does a switch do with a broadcast? A switch by default will send a broadcast out every port except the one it came in on. So watch what happens. That broadcast comes into switch 1. All right, so it's come in here. It's come in here like this. It's going to be sent out this port. Okay. You go out this port. It's going to be sent out this port. But guess what's going to happen now? You just got a broadcast that come in here, okay, on this port. And this also was sent out this way, by the way. It was sent out on both. And because it was sent this way, it's now going to be broadcast out here as blue. It's going to be broadcast out here as blue. And then next thing you know, it gets broadcast here. And blue and green are going. Suddenly you've got a storm. That frame is now going to start looping. And this is an absolute nightmare because this is what's called a broadcast storm. If you have a layer 2 loop, it will bring your network down in seconds. It will bring, I mean, literally, I've seen it happen. I've seen an entire network go down in a matter of seconds because of a layer 2 loop. This is why you should never turn off spanning tree unless you really know what you're doing. But you'll notice what's happening here. Look, there's no time to live mechanism at layer 2. So there's nothing to make these things stop. They're just going to continue to expand until it literally takes your network down.
So
The only way to
the number of package multiply between the 2 switch, right? Each time.
multiply, exactly. Yeah, it just keeps multiplying. The only way to stop it is to turn the switch off or to break the link, to literally disconnect the switch. However, we want redundant links because we want to be able to say if this path fails or if this path fails, another path will pick up. Well, spanning tree is a special protocol that allows you to build a loop-free topology that will keep backup links in an alternate state so that you won't have broadcast storms, but if a link fails, the other link can come up. So I'm gonna show you an example here. Here's a network. Switch 1 and switch 2 are connected. 0, 1 and 0, 2 are connected here. If we go to S1 and I do a show spanning tree, you will see that port 01, 02 are what are called designated and forwarding. So on this particular switch, you'll also see this bridge is the root. So this bridge has been voted to be the root. We'll talk a little bit about that in a second. Go to switch 2, all right. The reason we don't have a true loop is because you'll notice on port 2, FA02 is blocking. Okay, so it's an alternate port. It is blocking. So even though we have 2 links between S1 and S2, by default with spanning tree on, we don't have a loop because this port is being set to be blocked. If this fails, so if this link was to fail, so let's do that. Let's go up here. We'll go to config T int FA01 and let's shut it down. All right. Now if we do go back over to S2, give it a second. Notice how it's going to the listening stage. So it's going through those stages, listening, learning, and then we'll go to forwarding. Still, now it's learning. So it's listen, now it's learning. And eventually after about 50 seconds, it takes roughly 50 seconds, it will go to the forwarding state. So what it's trying to do here is to make sure there's not a loop being created. Now it is forwarding. So as soon as the link between switch 1 and switch 2 on FA01, FA01 broke, the secondary link came up and started working. This way, this is the whole purpose in spanning tree. I go back and do a no shut. You will see it should return back to, now automatically it went to a blocking state on this one and brought this one back into a listening. And now it's going to go through learning on that. So it's still listening. Now it's learning. And in a short while, it'll be back to forwarding. So we could have two links connected, but we don't have a loop because spanning tree is ensuring that we don't have a loop because it's putting one of those links into a blocked state. It's the whole purpose in spanning tree, to prevent loops.
Drop that and go do this. You gotta call your VP's telling you.
Hold on. Ebenezer? Somebody's
When the
breaking up
president
badly.
called that phone.
Has Ebenezer broke up? Any questions? Let's talk about, it used to be we had to get way deep in the weeds on spanning tree. We don't do that anymore in this version of the CCNA, but it is important for you to know these steps right here. And that is first, that in order to find out what's going to be the root, whenever you build a spanning tree, by the way, you have to have a root to build that spanning tree from to get a loop-free path. The root bridge is elected through an election process. And that process uses a thing called the bridge ID. The bridge ID is made up of the bridge priority, which, by the way, the bridge priority by default is 32768, plus the extended system ID, which is just the VLAN ID, and the MAC address. So by default, all machines, all switches on VLAN 1 have a bridge priority of 32769 because it's 32768 plus 1, 32769. And then the MAC address is appended to it to get your bridge ID. Now, to elect the root, the bridge with the lowest ID becomes the root. How do you remember this and how do you teach your students to remember this? This is how I teach them. I say, someone walks up to you, puts a gun to your back and says, I'm going to shoot you unless you jump off a bridge, but you can pick any bridge you want. You're going to pick the lowest bridge you can jump off of. I'm going to go find me one over a mud puddle and just jump off a mud puddle. So the lowest bridge ID is going to be the root. Questions about that? It's also important to notice the reason I use this extended system ID is because in spanning tree, there can be different roots for different VLANs. So you can actually switch the root for VLAN 10 and 20 and another switch the root for VLAN 3040. One of the big problems with the way bridge roots are picked, it uses the lowest MAC address. Unfortunately, typically our oldest devices in our network have the lowest MAC addresses. So you could end up, if you don't control who becomes your root bridge could be a 2960 sitting in a lab somewhere. So be very careful with that. So you elect the root bridge. That's the first thing you do. So you're going to look at all the bridge IDs. Whoever has the lowest priority or lowest bridge ID, by default, all the bridge IDs are bridge priorities are 32768 plus the VLAN ID. You can change that with the bridge priority command. So in this case, you've noticed someone's done that on S1, or they've issued a special command, which is switch port route primary for a VLAN. Once it is elected, once the route is elected, you have to determine your route ports. All the ports on the route bridge will be forwarding. That is an absolute. They will always be in a forwarding state. The other ports, the other switches had to figure out their best path to the route, and that will become their route bridge or route port. Okay. Here again, they're showing you default bridge IDs. If you don't change it, it's the one with the lowest MAC address, because they all have the same bridge ID. They all have the same priority. So which is 32768 plus 1. Thing that's going to make the decision then is the MAC address. And that can cause some very weird route bridge creation. You then have your route path costs, and that's just how you figure out what is the cheapest cost to find to the route, so that each one of these different switches can make their route ports, and they'll look at the path cost and make a determination. So switch 2 has 2 ways to get to switch 1. It can go across this trunk 1 or across trunk 2 and trunk 3. Well, if it goes across trunk 2 and 3, has a cost of 38, goes across 1 has a cost of 19. So that will be its route port. You then elect designated ports, and designated ports are ports on a route will always be designated. And then on bridges, you designate ports that are based upon whether or not, if it's connected to a route, it's designated. If it's not, then one of the things it will do is it will look at the bridge ID and see who has the lowest bridge ID. So like on this link right here, okay, if we're trying to determine which one of these will be designated and which one will be an alternate port, the S2, if it has a lower bridge ID, it would become, this would be designated, that would be alternate. And that's how this takes place right here. So looking at it, it says, hey, S2 has a lower bridge ID. And so this, I will put mine in an alternate state or a blocking state. Alternate is simply another spanning tree way of saying blocking. So alternate means it's a blocked port. If you have multiple, trying to find the route port from multiple equal cost paths. So let's say that switch 2 here is trying to get to the route. Well, it has the same cost either way. It doesn't matter, okay? If you have this, then what will happen is it will use the lowest port ID, okay? So like S2 here, you'll notice it can go across trunk 4, trunk 1 to get up here, and that would have the same cost as if going across trunk 2 and trunk 3. Well, in this case, because S2's port 01 would be used for the route port instead of 02 because it's a lower port ID. Now, we don't get into a great depth on this spanning tree for the CCNA, but it's just important that you understand this portion because it has a very huge bearing on the reason for our next chapter, which is Ether channel. Questions about spanning tree? Notice here. Oh, go ahead. Go ahead.
Okay, so I have the 2 questions.
Okay.
So this spanning trees look like the same terminology used in graph theory, right? You have a graph, and then you want a tree structure that cover all nodes, but there's no loop in there. That's
Correct.
basically the same concept.
And it's
Now,
very similar to Dijkstra's algorithm, the
Okay.
shortest path first algorithm.
Oh, okay. So the next question is, now how do you assign the so-called ID? That I forget the first ID called.
The ID, you can go into the switch port and set its ID.
A priority ID. How do you set up the priority ID?
Right, you do spanning tree. You can do. Well, I need to go. It'd be on actual be on the interface. Spanning tree. Oh no, hold on. Spanning tree, VLAN, priority, VLAN 1, and then you set your priority right there. So you would set the priority, it should be in capital, by the way, but you set the priority there. So by default, remember the priority is 32,768. Let's do this. Let's try something. Right now we can see that if I do a Control Z and I do a show spanning tree, you'll see that this bridge is the root, okay, because the priority is 32,768 and here's the MAC address. And so it must have a lower MAC address than this switch here. So let's do show spanning here. Okay, so yeah, 28 AF.
32,769.
Yeah, let's undock this and we can pull this out. We'll be able to put this over here. And we'll pull this one up here and we'll undock it. Oh, if you've never undocked, you can actually pull the devices out like this. If you have multiple screens, you can do this. So you'll notice that at this time, the priority is the same, but 28 root ID. Oh, that's the root ID. Sorry, bridge ID is down here. So 28 AF is smaller than 3473. So this switch 1 becomes the root. But now what we're going to do is we're going to go in global config and we're going to do spanning tree VLAN 1 priority. Let's do 4096, which is real low. In fact, that's the lowest it can go. I believe, let's do a question mark. I think that's the absolute lowest. And go, yeah, in increments of 4096. The lowest you can have is 4096. So let's now do this. Now, one of the things that's going to happen is if you do a show spanning now, more than likely, it's not going to be, oh, it did switch over immediately. Good. Okay, that's kind of unusual. Typically, you have to reboot. But notice now, before switch 1 was the root, okay, and had the priority of 32,769 and the MAC address was lower, so it was the root. But I went into switch 2 and gave it a priority of 4097. Now this is the root. So you'll notice switch 1 is no longer the root. Switch 2 is now the root.
So the switch 1 and switch 2 will share the same spanning tree there. Oh,
Yes,
different.
yes, they're sharing the same spanning tree.
Okay.
They sure are. Yep. So if I do a show spanning tree, like I said, you're seeing it here. You're seeing that they have spanning tree for VLAN 1. They've only got one VLAN, so that's the spanning tree they're sharing. If there's multiple VLANs, there would actually be a spanning tree instance for each VLAN. Okay. Questions about that? All right, excellent. So you've seen then how we can set our spanning tree. You've seen that when you go through these different states, it can actually block traffic from going across your links. One of the things I will tell you is on this particular chapter, I would pay attention to this section, and that is the different versions of spanning tree. You don't have to get crazy with it, but spanning tree has been around a long time, and we've got different versions now. Some of them, like the rapid spanning tree, superseded 8021D, which is our old version. And so we've got a little different naming of the states. It used to be we had blocking, listening, learning, forwarding. We now have under RSTP, typically they call it discarding, learning, and forwarding. The funny thing was when we showed you the example of the interface coming up, you'll see it actually said listening, learning. You also notice here that this is using IEEE spanning tree protocol, which would just be the typical 8021D. So that's telling you IEEE protocol, 8021D, not RSTP. You can change the mode, and I'll have to remember how to do that. Spanning tree mode, that's it. There you can change it. So you see that these support MST, PBST, per VLAN, and rapid spanning tree mode. So if you want to change it, you have to change it to rapid, and then each device on the network has to have the same setup. So we need to do spanning tree mode rapid, and now you do a do show spanning tree, do show spanning tree And you'll see that we're now running RSTP instead of IEEE. Okay, so we've changed our mode. Again, that's not something you really do much in the CCNA Academy anymore. It's just something that's nice to be aware of. All right. But let's look now, and we've got a couple minutes. I want to look at this, and that is spanning tree is great, but wouldn't it be nice if we had a way to connect multiple physical ports on two switches and make them appear to be one large port that has more bandwidth? So in other words, can we take and create through link aggregation a bigger channel through which to send information? Now, by default, spanning tree will block one of these two redundant ports, one of these two redundant links. That way you don't have a loop. But with Ether channel, we can actually bundle or channelize these ports together so that it appears to the switches as one physical port. It's called a port channel. The advantages: load balancing, speed. You also have, believe it or not, you can do most of the time you can do up to 8 interfaces. And they all have to be the same type, and you can actually go further than 8 on some devices, but they have to be the same speed and the same type of interface. They also have to be in the same mode, so they have to be an access port or a trunk port. You can't channel a trunk and an access port. But with these, when you do it, you can actually then imagine if you had 8 100 megabit ports, you end up with one channel that looks like it's 800 meg send, 800 receive. That is very advantageous. All right. We do have a couple protocols available. One is called PageP and one is called LACP. PageP is a Cisco proprietary protocol, and it is designed to be used between Cisco devices only. And it has the mode of either on. And if you do on, that basically just turns channeling on. So you really have no negotiation. And then you have 2 different states with PageP, desirable and auto. Auto says, I will become a channel if the other side wants to be a channel. Okay. So if one side's desirable and one side is auto, it will become a PageP. If one side is auto, the other side is auto, it will not. If both sides are desirable, yes, you will get a link. So you'll notice here, if PageP is on and on, you get a channel. If you got on and desirable or auto, no, because if you turn it to on, there's no negotiation. If you do desirable and auto, yes, or desirable and desirable, you get it. All right. LACP is exactly the same as PageP, except it's an open standard, IEEE standard, and it has active and passive instead of desirable and auto. Active is negotiate, try to become a LACP channel. Passive is become a channel if the other side asks to become a channel. So what I want to do is I want to go in here real quickly while we got a couple minutes here, and I'm going to make a channel for you. So first off, we see we've got port 01 and 02. Now there's a couple things I do want to mention here. One is when you have this and you're creating channels, you can either make both, go ahead and put these into a trunk, make these trunks, and then put them in the port channel, or you can put them in the port channel and then have the port channel be the trunk. I can show you both ways, but this is the way that's most common, the way I typically do it most often is this. So we'll do this. We'll go interface range FA 0/1 to 2. All right. We're going to do port dash port group IP port group. That I'm drawing an absolute blank, folks.
Can you show the ports?
Channel group, sorry. Channel group. All right. And then you give it a name, typically just one. So channel group 1, mode, and I'm going to make this, and here you can see all your modes. active, auto, desirable, on, passive. And I'm going to make a like piece. I'm going to make this side active. Okay. I'm going to go over to switch 2 and go interface, range, FA01 to 2, channel, group 1, mode active. And one thing you'll notice is as soon as you do this, it creates a port channel. So if I do a do show run now, you're going to see a new interface called port channel 1. And so what I do, and what typically I like to do is this. I then go to interface port dash channel 1, switch port mode trunk, go back over here, do the same on my channel group over here, or interface port channel 1, switch port mode trunk. Now if I do a do show run, you will notice that a couple things have happened here. We've taken the 2 interfaces here, we put them in a LACP ether channel, which created this port channel group. By the way, this number right here creates this port channel. And then when I put switch port mode trunk onto the port channel, it automatically places that onto my fast Ethernet 1 and 2. Now if I do a do show interface trunk, you'll see that I have a port channel that is on trunking native VLAN 1. So if I go in here now and do a switch port trunk native 99, let's just say native 99, native VLAN 99. Okay. I had to create VLAN 99, but that's okay. You'll notice what it does now. It's actually got a mismatch with switch 2. So let's go over here and we'll fix it on this one. We'll do switch port trunk native VLAN 99. Now if I do a do show run, look what's happened. It actually adds that under both of my port channel and my switch ports. So everything I put on this port channel gets applied to the physical ports. But you'll now notice if I do a Control Z, do show interfaces trunk, or interface trunk, you'll notice that my native VLAN is now 99. Okay. And if you ever want to see your ether channel, here's what you do. You do a show ether channel summary, and you'll see now that I've got one ether channel. I've got these 2 ports bundled together in a port channel. That's what the P means. And the protocol being used is LACP. So it's up and in use, layer 2 in use as a port group. And that was how simple it was to create a port channel that is now 200 megs send, 200 megs receive, because these are fast Ethernet ports. Now, if I do a show spanning tree, watch this. Show spanning tree, it only sees a single port. It doesn't see those 2 ports as 2 separate ports now. It doesn't see FA1 and FA2. It sees only the port channel as a single port. So that's why it's not blocking one of those. Let me show you something really cool. Let's say interface FA01 goes down. Watch what happens to the port channel. The port channel doesn't go down. One of the links is down, but the entire port channel doesn't go down. So if I had 4 links like this in a port channel, then one link can fail and it will still stay up. Believe it or not, one of the biggest uses we have for this in today's world is the following. We take an ESXi server. So here's a server. This is VMware. Okay. It's ESXi. So it's got all our virtual machines on it. So we got all these virtual machines that are on this machine here. Well, we actually create a port channel of multiple links to the server. And all of these are part of a port channel or an ether channel. So these are all ether channels. so that we can support larger bandwidths to our servers, and we can support a single link failing. So if we have a link fail, this link right here breaks, or even these two links break, doesn't matter. We can still get to our virtual machines because they're sitting over here inside of this server. That port channel stays up to the switches. And by the way, this port channel goes in here to what's called a V switch. It's actually in the ESXi a V switch, so it's a virtual switch. And that virtual switch uses multiple actual NICs. Each one of these are a different network interface card, but it will actually make this appear to be one Ether channel. That's where Ether channel is the most used. Well, not the most used, but it's one of the most useful uses today in our modern data centers. Questions?
I wonder, will that be more or less expensive to upgrade the two switches, say from like a base 100 to like a 1G?
Right. Well, let me tell you, I agree with you, but one of the things we're doing, like in my network in my data center, we have we have two very high-end switches. We have my spine switch, which sits here, and we have 100 gigabit links. Okay, so these are 100 gigabit per link seconds. We still do to each one of my leafs in my data center. So this would be a leaf switch. We still do Ether channels of 100 gigabits. So we've got 200 gigabit send, 200 gigabit receive. And also, if one of these happens to fail, I still have connectivity. So
Yeah, that would be the big issue, is redundancy.
Redundancy. Yep, that's one of the biggest issues, is that redundancy. I agree with you, Dr. Hugh. More than likely, it's cheaper. As a stopgap method, it's good to use Ether channels, but even in very fast networks with very fast interfaces, the redundancy alone makes Ether channel useful.
I agree.
So it does have a advantage.
Yes, it has an advantage. Yep, sure does. And if you had more than two links, okay, one of the things that you can do, and this is something that's way beyond CCNA level, but you actually have different, I say it's 4 links, there's actually different ways to do the queuing to send things across those 4 links. So there's different ways to tell it how to do it. And you can actually, in Ether channel, go in and modify how it will determine which link is used and how it round robins basically across through those links. Again, way beyond what's in the CCNA, but it is a concept that's out there that you can actually modify those parameters. All right, excellent. Okay, any questions for me about Ether channel? I'd like for you to work on that, work on these items here. I've kind of sent a thing out saying that this is where you should be right now, working on these packet tracers and these labs. Remember again that our labs are on NetLabs. So if you go in here and you're logged into NetLabs and you want to do the Ether channel lab, you would go new lab reservation, schedule lab for myself. You would scroll down to find your class, whatever it happens to be. So if you're in the summer class, and then you would pick the CCNA 2, and here's all the classes. So there's the lab I'm in right now, this implement Ether channel lab.
Need that.
Okay. All right, everybody, I'm going to stop the recording. So I'm gonna
Hey,
stop.
Kevin. Hey, Kevin.
Yes.
Hey, Kevin, it's me.